Hello guys, welcome to another grand interesting video on our Be Aware channel. And in this today's video we are going to learn about our next default process flow, and that is on queues. So we have already created a video on understanding default process flows for the source object, and in this video we are going to learn about creating the default process flow for queue. So this is going to be a very interesting video, so stay tuned with us till end of this video. We bring exciting educational content related to simulation, industrial engineering, health awareness, finance, and there are a lot of exciting stuffs we are going to bring you, and some of those are already available at our website beawarechannel.com. So do not forget to visit our website beawarechannel.com and our YouTube channel Be Aware. So hit a like to the videos and share our videos with your friends, and if you haven't subscribed to our channel, do subscribe to our YouTube channel. It really motivates us to bring such educational content just for you. So if we are now going to look at this video in simulation model, what thing is the different thing you are able to observe in the simulation model, right? Let me know in the comment section what is that which you see is different than it has to be actually. Okay, so the correct answer for this is going to be the processor. See, the processor 1 which you see here is servicing one part at a time. We have a queue in here which is Q2, and we have a processor 2 in here which is servicing the parts, but if you see, the parts are piled up onto the processor. So the similarity which you see between two objects, that is Q2 and processor 2. So what you see here is that Q2 functionality is getting resembled with processor 2 functionality, that is, both are storing parts just like buffer. So what we have done is we have converted our processor 2 to act as a processor, as well as it is going to act as a buffer, stacking up the parts perfectly like a queue. So in this today's video, you would be able to understand now what is the agenda for this video. So the agenda for this video is we are going to learn this process flow, that is default process flow for the queue, and now you would have been able to understand what can be the applications of the default process flow. So without making much of our time, let us begin understanding how can we convert a processor to act as like a queue with just a clicks. So we are going to learn that now. So before we could learn, let me reset this, okay? And what I'm going to do is, whichever my process flow I have already connected to this, I'm going to delete that process flow. Now let us reset and run and check whether my queue now acts like that. So if you see, my processor 2 is now acting just like my processor 1, and the functionality which you were able to see before, that my processor 2 was stacking up the parts just like my Q2 or just like my Q3, is not into activation right now. Why? Because we removed that process flow, that default process flow, right, which was making this processor to work like a queue. So now I'm just going to bring in the process flow in the picture. Let me drag in this queue process flow in here. So this is a ready-made process flow which is available. You just need to objects to be attached to this process flow. Once you attach the objects, your process flow will start working fantastically, right? So let me just reset this, and what I'm now going to do, and now our real crux of the story, that is real magic, starts in simulation modeling. So if you haven't liked our video, please do hit a like, do share this with your friends, and do not forget to subscribe to our YouTube channel, guys. We need to target at least 5,000 subscribers till our next October 2024. So support us on subscribing, sharing and liking. So what we are going to do is we're going to attach this processor, and that's all. In a single click, the moment you are going to attach the processor, we're going to reset this and we're going to run this. So when the simulation model is started to run, right, here is the thing. Our processor has started, or you can say the processor has converted to the queue. It is just as simple as that. But we are not just going to learn this, but we are also going to understand the elements of the process flow which are present in here. So let us reset the model, let us zoom in the process flow and let us come in here. So this process flow, if you see receive item at the model start, it is nothing but just creating a token, at quantity 1 with 0, and then you are just applying this custom code with the receive item from the current, right? So this code, if you make it off, still it is going to work because it is not yet customized. It's a simple thing. You can add the stuffs in bottom here. You can add whatever customization you want to do in this. That is doable. But currently we're not going to look at this because our source is connected to the queue supplying the parts, and then it's supplied to the processors, and then it comes to processor 1. So that's not a big deal for us. So let us understand this queue item process flow and update item locations process flow. Now if you could look at what we are doing is, on item entry, current instance is nothing but the processor 2. On entry, we are going to assign that as an item, okay, and then we are going to receive that item from this. So you can again select which port you want to receive the item. But I would like to bring one point in, say, like for example, even if you put it here like I want to receive it from the port 2, what you're going to see is that my processor is going to act like the processor, not queue. Why? Because we do not have our port 2 in the picture. So when we select this as 1, hopefully this should be getting converted into a queue. So this is how it is. So based on here you can select or uncheck this. If you want to take the parts from multiple ports, you can select it out this. Currently it would be a default. We are just going to receive from whatever available port we have. Then we have a subflow here, which is going to update the item locations, and we are going to run a quantity of 1 token throughout this update item locations, okay. And when you go in here, we have another trigger that is wait for event on exit, where we are going to item.match. Now this is again not a big deal. You can have it none because currently we're not matching anything. It's like whatever comes, that is going to get exited basically, okay. So that's what it says. So whatever comes in, that is going to get out. Then when we look at breathe, okay, we have 0. That's again a delay customization. You can add the delays into that if you want. And then we have another subflow, which is going to run. So let us see, both of our subflows are connected to this location, okay. And if you see, it's also written here that this logic mimics the stack inside queue item placement from the standard queue, okay. So I'll just reset the model because it's making it bulkier. So this is how these are the specifications of the parameters used in the process flow, which are customizable. You can customize it, but you might have understood how the process flow is driven here for queue items for it. Let us now look at update item locations. Now if you look at, this is a subflow which starts here, finishes here, also finishes here. So what it says that whenever my queue is going to be empty, I'm going to end my subflow immediately because I'm just going to place at its starting point here. But now say I have a first part here, then what I am going to do is I'm going to go down in this loop and I'm just going to click on this, and this is assign labels, And in assign labels, if we could look at, we are setting up all these parameters of locations, right? So current Z location, max SY and XZ, these are basically getting updated ahead in this loop. If you see here, these are values are getting updated. When we talk about X fringe right, okay, when we talk about X fringe right, we have certain code of 0.96 into this of size and this of. So I'll show you what the change happens if we change this value. And I really liked that the values, if you change in here, it is really giving you a great structural thing. So if I make this 2, and if I make this as 1 rather than 0.96 and stuff, you can see what happens. Now this Q, which was ideally starting from here, is now starting from a delta of 2. Also, you might see that initially I was able to create only 4 rows, but now I'm able to create 5 rows. Why? Because 1 divided by 2 becomes almost 50%, so it's 5. When you do 0.04 divided by 0.96, it becomes 4. So basically that is what it works like that. So when I reset this, and if I do this way, it will be having the distance going to be this way. And now if you see, I'm having almost 3, 6, 7, 8, 9, 10, and the things are going on great ahead, right? So this is what. So based on your details, you are going to change out in here. Okay, the proportion, the way the proportion you are going to change out here. Now our Y direction is this, our X direction is this. So based on that, these configurations of the Q size can be changed. Okay, so if I just reset this and let us bring this to our original position, and we will now vary our X directions. So now if you see, I'm starting from here, I will have 4 rows and that's all, and I'll start stacking up in my X direction. Now let us make this here, just we made it for X, 2 and 1. So if you see, I am started creating my thing in this direction here, this directions 1, 2, 3, 4, 5, 6 in this directions. Initially this Q was been created towards the left, what we can say, towards the left, but now with this code it's getting generated towards right. So now let me just make this reset because the right side is bigger. Again, I'll just make that normals. So these values, if you just change in here, your what we can say, the Q, the way the Q is going to get stacked gets changed. I'll show you another important parameter which impacts your Q visualization or Q stacking. This is that Y increment. If you make this Y increment to 2, this becomes a great picture. Just look at this. What is the difference you are getting to see is that every alternate area is getting stacked and used as a queue. This is the stacking way. So if you want to use this way of stacking, you can greatly go and get spatials, and you can change the Y increment to -2. Okay, and this is where it changes. If I make this -3, what has to be supposed is like this is what happens. So the delta between these Y direction is of 3 quantities. So if you see, you will have this a gap between each of these 2 combinations and 1 gap, 2 combinations, and then you are going to have 1 gap. So this is how it is going to work as, and it looks great, really great. So this is how the things are going to be very good for visualization by just changing the spatials in this direction. So this is a very important thing, and I think that in a simple cube you cannot change the allocations of the parts being stacked in the queue, but certainly by using this process flow you can make such beautiful arrangements of stackings in the queue, which really looks great. So this is the advantage of using this default process flow, and if you go in ahead of the loop, then there are certain calculations it's easy to understand. We have mostly the assigned labels being used, which are referring the values in order to make a calculations done, so that our parts are assigned in the sequence considering x, y, z all conditions. So this is how it becomes crucial. So this whole process flow is for that, where you're going to set a locations for your part based on the calculations you're doing in a backend at all these green little dots assigned labels. So you do that, then you check whether my y-axis I can fit or it is filled, where I have a capacity for x. If not, I have to go to y, and then I have to create my x capacity. So that's all is there in detail calculations. Like it checks, like I go and adding my x space, but now x is full, then I will add my y space, and then I will go on filling my x space. So that's all is what the logic's been discriminated here. And here at last, if you see here, we are checking the index, and that all is done. So let me know. So basically more items, what this does is the total number of items in the queue, we are going to run this loop again and again. Because what happens if my single part, say this part, goes out for this processor, I have to rearrange all the positions of these little boxes such a way that this will come back, then this will come back, then I will have this coming back, and then I'll this coming back, and I'll this coming back. So this way all my boxes needs to be rearranged, and that is taken care by this code more items, which sends my all items by this check of location fixing. So this is all about our queue default process flow, which is available in Flexsim. You can use that to customize any of your fixed resource into a queue. Also, we learned that not only we can transition our processor into a queue like stack inside queue, we can also modify the spatials in this code, and have such a beautiful stacking arrangement being generated. So we saw that what different things and stuffs we can do with the spatials. So let me just reset this model, and this is how basically it is going to work on. So that's all for today. Let me know if you have any queries in this process flow in the comment section, or you can reach us out from our website contact us page, or you can also reach us out via email, which is available in our YouTube description. We have also listed down some of the affiliated links, guys. Do purchase your Amazon shopping by using that links, because it is not going to add up the cost to your products, but it's definitely going to support us by getting some of the perks from Amazon. So do check out our affiliated links in the video description below. So that's all for today. Let us know how was this video, and do not forget to like this video, share this video, and subscribe to our YouTube channel. Let us meet in another grand interesting video understanding next default process flow. Till then, stay safe, stay simulating.